In this video, I'm going to work out the remaining lecture problems. This is out of 3-3. 29, I went ahead and changed like that. Remember, the -1 flips it over. So we'll use the quotient rule now. So the quotient rule is low d high minus high d low all over low squared. So I'm going to start filling that in. F prime is the bottom function, 2t minus 2. Times the derivative d dt of the top, which is 3t minus 1, minus the high function, which is 3t minus 1, times the derivative d dt times the low function, which is going to be 2t minus 2. And that's all over the low function squared. Right, if I work that out, okay, I get 2t minus 2. The derivative of 3t minus 1 is 3. Minus 3t minus 1. Derivative of 2t minus 2 is 2. And then I'm going to leave the square on the bottom, hoping things cancel out or something. Okay, so let's see. Let's do our top. So I'm going to get 6t minus 6. And then minus 6t, and that's going to be a positive 4. All over the square, 2t minus 2 squared. The t's go away, and I get negative 2 over 2t minus 2 squared. We could go further if we wanted to. I could take out a 2. I'll do it. So this is negative 2 over 2 squared times t minus 1 squared. Notice I just separated the 2 that would be factored out. This is going to give me a negative 1 over 2 times t minus 1. It didn't really get it didn't get simpler, but there it is. All right, so the quotient rule is just going to take a little bit of time. Let me shrink this one up so I have room. Cool. All right, I'm going to put that right over here so I have more room over here. So h of x is already in the right form, so h prime of x. It's the low d high, that's the rule up here, didn't change. So low is x squared e to the x times the derivative d dx of high, x plus 1, minus the low, x squared, the low, high, x plus 1, and then derivative d dx of low. That's just following the formula. So if you got confused there, I kind of did, just look back at the formula. All right, and then we get this squared. Okay, so I'm going to follow this. Oops. All right, this is equal to, okay, I keep the bottom. We could just square that right away, but I'll wait. And then I get x squared e to the x, and then the derivative of x plus 1 is just a 1, minus x plus 1 times the derivative, and we've got to use the product rule here, unfortunately. So I get x, derivative of the first, so d dx of x squared times the second. Let me move this because I don't want to cram it in there. All right. Then I take the derivative of, it's the first one. Where am I at? Yeah, just x squared. And then be careful here. This is minus the whole thing. So plus derivative d dx of x plus 1, and then times the second, which is just e to the x. Hold up. Go back. I'm confusing myself. I want to go all the way back. Take all that out. Take that out. Take this out. Okay, let's start over here. I think I confused myself, which means more than likely you're confused as well. So the high function in this case was the x plus 1. And then I need the derivative d dx of that part, which is going to be x squared. And I'm going to put a bracket here. There we go. Times e to the x plus x squared times the derivative of e to the x. There we go. I know it's stupid complicated, but that's okay. That's the worst part. And then I have x squared e to the x minus x plus 1. I'm going to go ahead and do the inside of that thing. Okay, derivative of x squared is 2x e to the x plus, and then this is just going to be x squared e to the x because the derivative of e to the x is e to the x. all over. I'm going to go ahead and multiply these out. I get x to the fourth and e 2x. Just multiply the powers. Okay, I keep going. I got x squared e to the x. And then we could multiply that out. Gross. I think we could stop there. I think that's going to be our best bet. Yeah, let's leave it there. I'll leave the algebra to you guys. So you could multiply that out. It is a pain because we have a binomial times a binomial. You have to use FOIL or a box there. But it takes a little bit of time, but I don't think looking at it, and I debated for a moment working it out, but I think you guys can handle that, and I'd like to keep my videos shorter. All right, let's look at 56. Okay, first thing I'm going to do if I define the derivative, I see that function is kind of nasty looking because it looks like I can multiply by a conjugate. So I'm going to do that because I can see, and I've done it for a while, I can see it's going to simplify it. So I'm going to multiply top and bottom by the square root of x plus the square root of a. Square root of x plus the square root of a. If I multiply the bottom, okay, I remember the non-conjugate side I don't touch. So let me go down instead of to the side there. Okay, we get x minus a times the square root of x plus the square root of a. And then on the bottom, I'm going to get the squared. I'm going to get x minus a when I multiply that out. So that means my function is literally just the square root of x plus the square root of a. So this derivative would be much easier because this is just the x to the 1/2. And then that's a constant. A is a constant. So y prime would be 1/2 x to the negative 1/2. And then the derivative of the constant is gone. 0. And then this turns into 1 over 2 square roots of x. So sometimes you can manipulate, like right here, we manipulated y before I even took the derivative. I made it simpler because I had an idea of what it could look like because we've done so many limit problems in the last couple of weeks that I was like, oh, that'll make that simpler probably. So I went that route. All right, I have a few more here. I think 2 more problems. The last one has multiple parts. They want us to find f prime and f double prime. So we're going to use, again, I'm going to write out the quotient rule because we're going to need it. This is low d high minus high d low all over low squared. Okay, so this f prime will follow that same formula. So low x plus 1 and then d dx of the top, which is x squared minus 7x, minus high, which is x squared minus 7x, times d low, d dx of x plus 1. And that whole thing is going to be over x plus 1 squared. So I got x plus 1. The derivative of that inside is going to be 2x minus 7 minus, I got x squared minus 7x times the derivative of x plus 1 is 1. And that's all over x plus 1 squared. We can simplify this probably. I'm actually just going to leave it because I think you guys can do that just fine. So you'll multiply the top out, see what cancels. You'll probably have to factor at some point, and hopefully something cancels. Oh, actually, it asked for first and second, so I am going to continue. Okay, so let's finish, and then I'll shrink this up to get my second. So I got 2x cubed, and then I'm going to have a 2x and a minus 7x is minus 5x, and then minus 7. And then minus, this is just going to be x squared minus 7x, all over x plus 1 squared. And that's going to be, okay, I get 2x, I put cubed there, and I meant to put a square. I'm sorry. Some of you guys probably caught that already. I got 2x squared, and it's going to end up being, because I got x squared minus, 2x squared minus x squared gets me an x squared. Negative 5x minus a negative 7x is 2x, because it's positive 7. And then I get a minus 7 here over x plus 1 squared. And I'm really hoping one of those will factor out, and they do not. So now we get to take this answer, and we get to do the quotient rule again, but on these numbers. So now, second derivative, it's the same formula, but I use it on what's here. So low d high. So it's going to be d dx of x squared plus 1, or x plus 1 squared. I was really hoping that was going to factor. Now I'm like debating if I made a mistake somewhere. Okay, I don't see it. So we'd have to do the derivative of this. I'm just going to write it out, and then we'll leave it. You may have to do something this complicated in your homework, but like test-wise, no, because it's just too much. Okay, then it's high, x squared. I don't think we're using the right ones. So this becomes, okay, low would be the square, and then high would be x squared plus 2x minus 7, minus high, which is x squared plus 2x plus 7, times, oh, that's supposed to be derivative of that. Hold up. Forgive me, guys. Sorry, I just got done with class as well. Told you guys I would record this right away, so my brain's a bit tired. So low, it's x plus 1 squared times d dx, there we go, of the high, x squared plus 2x plus minus 7, minus the high function, so x squared plus 2x minus 7, times d dx of x plus 1 squared. Sorry, I'm in the corner there. And that's all over x plus 1 squared squared, which is going to be to the 4th. There's my second derivative. We could even take the derivative. The problem is you guys are going to have to multiply that out, which is fine. Maybe I should continue. So I got x plus 1 squared, and then this derivative is going to be 2x plus 2, minus, and then x squared plus 2x minus 7. And then the key to this part is that x squared plus 1 squared is just x squared plus 2x plus 1. So I'll take the derivative of that instead. I get 2x plus 2. All over x plus 1 to the 4th. All right, we can see a couple things here. If I factor out a 2 out of this, I get x plus 1. So I'm going to get 2 plus x plus 1 cubed. And then I don't think it's going to get much better. We get minus 2x plus 1 over x squared plus 2x minus 7. And all of this is over x plus 1 to the 4th. So I think the last thing we could do is maybe just take out an x plus 1 from everything. Oh, and I dropped that first one, but there's only one that's going to go away. So 2 of x plus 1 squared, and then x plus 1 cubed. Again, it's really messy. I could even keep going, and things probably would cancel out nice and pretty for us. Actually, I'm just going to keep going while I'm here. So this is going to end up as 2x squared plus 4x plus 2 minus 2x squared minus 4x plus 14. All over x plus 1 cubed. Okay, the 2x squared and the 4x go away, leaving me with a 16 over x plus 1 cubed. So we actually cleaned it up quite a bit. We want that in case we'd have to take the third. The third would be easier now. Or if we were wanting to create a formula to plug things in, I would much rather plug things in here than here. You know, this would be a lot of x's to plug in and a lot of dividing, while the simplified term would be the easiest to plug in. Also, if we're talking about programming a computer, we want the least amount of steps possible to save storage space. All right, 65 is our last one for this video. So population growth, they gave us this function, and they want us to find the instantaneous growth rate of the population for t greater. Let's just find the derivative. So to find p prime I mean, okay, low d high, I'm going to write down the definition, low d high, high d low, all over low squared. So I'm going to start this out. I'm going to make that prettier. Okay, low would be t plus 2, and then d dt of 200t minus high, which is 200t, times d low, d dt, t plus 2, and then it's going to be over that whole thing squared. All right, so I work this out now. Okay, t plus 2 stays. The derivative of 200t is just 200 minus, okay, I get 200t. And then that's just going to be times 1, so I'm going to leave it like that, over t plus 2 squared. And I'm going to actually multiply this out because it's going to simplify for us. So we get 200t plus 400 minus 200t all over t plus 2 squared. And that's going to end up being a 400 over t plus 2 squared. So that is the instantaneous growth at any t B asks for the same thing, P prime of, and they want us to plug in 5 though. So I use, instead of running through the whole formula, I just plug it in the equation that we found, 400 over 5 plus 2 squared, and that's going to be 400 over 49. 7's the only thing that goes into 49. I don't think 7 goes into 400. I may be off there. No, 7 doesn't go into 400. So it's 400 over 49, and that is a population growth. And if I take a look, they didn't even give me what T, so people per, and then time, they didn't even say what time is, so per year maybe, if we're talking population. Maybe, but the 400 over 49 is good. C says estimate the time when the instantaneous growth is the greatest. So we're looking at P prime of T equals 400 over T plus 2 squared, and this is only for T's greater than or equal to 0. So I want you to notice as T gets bigger, my denominator is going to get bigger because I'm going to add 2 and square it. So it's going to get the biggest, the smallest as we go out. It's the biggest when T is the smallest. So if it's greater than or equal to 0, the biggest it's going to be. So P prime is at max when T equals 0. And the reason being is if I make T bigger, the denominator gets bigger, which makes it closer to 0. Okay, I got one more problem here. D says value interpret the limit as T goes to infinity, and they want to know a P. So it's of this function, 200 T over T plus 2. Now remember, for these limits, just from the first test, I'm going to divide for infinite limits by the biggest variable, which is T. So I'm going to get 200 over 1 plus 2 over T. I take that limit. The 2 over T goes to 0. Everything else stays the same, which means we got 200. What this means, if this is a population function, that the population will max out at 200. What this means is, I know in high school we learn functions of populations that go up forever and ever and ever, but the deal with populations is we're limited by a bunch of variables. We're limited by food, which is limited by prey or vegetable growth, which is also limited by water and limited by how much crop do we have to begin with, which is limited by how much rain we're getting, which is limited by a bunch of things. So the population never actually just goes up and up and up. It's limited by how much the environment can sustain. So typically we get what's called a logistic equation, and that's what's happening here, is it will have a max because the population is getting bigger, but it can't sustain past the 200. All right, I hope these help.